So welcome everyone to today's webinar. As a reminder, the webinar is part of the ADJanet and Dataninja Data Journalism Training Program. The enrollment to the program is now closed, but we welcome you to sign up to the waiting list so that you can receive further updates from us about the program. So today we have two guest speakers with us today, Niccolò Salvini and Davide Del Monte, who will tell us about how journalists can use data to investigate corruption. The webinar will also have a practical component on using R, and in particularly on using the package developed by the CORESOI project, of which Niccolò and Davide are part of, and of which they will tell us more. So I leave the floor to you guys.
Thank you. Hello, everyone. I need to share my screen. Hope it works. Let me know.
Yes, I'm having problems with the audio. I don't know if it's only me.
Now, is it better?
Yes, perfect. Thank you.
Okay. And can you see the presentation?
Yes.
Okay, so hello to everyone again. I'm just introducing this webinar about the CORESOI. What is CORESOI? Niccolò will explain better later, but basically is the tool developed by the CORE project that aims at help investigative and data journalists to analyze data about public procurement. The CORE project is a European-funded project, basically devoted to the identification, definition, and development of new indicators of risk of corruption during emergency period. There is plenty of indicators of corruption, but before this project, coordinated by the University of Perugia, there were not indicators for specific emergency period, as for example, the COVID-19 period we passed through in the last 2 years. So basically, we will talk about how to identify, investigate, and then prevent corruption during this workshop. Keep in mind that corruption is a very particular and sophisticated crime because it's difficult to be investigated for several reasons. First of all, because it's a pact between two parties who have an interest, a common interest in keeping what happened a secret. So no one has a benefit from disclosing a corruption pact. And secondly, because the corruption is a crime without a visible victim. There is no corpse, there is no a robbery, there is no the destruction of some goods. So it's very difficult to identify corruption because of this. So, because of corruption is a complex and sophisticated crime, we need sophisticated and innovative investigative tools in order to identify corruption cases. We are talking about corruption. We want to identify corruption cases. So the first question we have to keep in mind is corruption measurable? Barely. A lot of organizations are trying to measure corruption. We have several indicators from the Transparency International Corruption Perception Index to the World Bank Index and many others. The Eurobarometer, for example, but we can have only a glimpse of the real dimension of corruption. Is corruption predictable? Partially. We need to exercise very complex risk analysis, risk assessment in order to try to prevent corruption. So what can we do? We are journalists, we want to work with data, and we know that data can support us in our work. But in this case, as I said before, we have to use big amount of data we will talk specifically about public procurement data that are a lot of data, are complex data, are data made of several metadata that we need to analyze. So basically, we have to learn how to manage and analyze big data lake. We must rely for this on tools that can identify potential corruption risk, traces that can open up real investigative leads. As I said before, there are several tools and indexes that try to identify corruption. What we developed during this core project are two new tools that we hope can help you in your investigative work. First of all, the core dashboard. The dashboard is the first step to understand the risk of corruption in public procurement. It's useful for carrying out preliminary analysis, for understanding the general situation, because the dashboard provides a series of visualization of the indicators of corruption during emergency periods. The dashboard is, of course, a dashboard, so I think that there is no reason to explain it before, to explain it better. The dashboard is based on 4 European countries: Italy, Spain, Portugal, and Ireland for now. We made the dashboard around the calculation for the indicators of corruption in emergency for the COVID-19 emergency. As an example, here we have, for example, the page dedicated to the Portugal COVID-19 emergency, and as you can see, there is the list of elementary indicators and the composite indicator that is the aggregation of all the elementary indicators that you can choose and basically see how each province, region, contracting authorities, and companies is evaluated by these indicators. This is another example of the results of the dashboard for Italy. In Italy, we calculated the indicators also for other emergency. In this case, for example, we calculated them for the forest fires, an emergency that we have basically every summer. And so again, you can choose the indicators you want to look at and see how contracting authorities and awarded companies are evaluated. Why is important to have a look at the dashboard if you want to start data or investigative work? Because we have a lot of information that you can use as a lead. For example, here we compared a real case of corruption happened during the COVID-19 emergency in Italy with the assessment of our indicators. In this case, called Fiera di Bari, the Financial Police of Bari carried out an investigation against several individuals, including entrepreneurs and a public officer of the Puglia region. They've been investigated for collusion with the head of the regional civil protection, Mario Lenario, who was then arrested then. You can read the case here, but what is important here is that you can look at the red flags on this case, looking in the dashboard for the awarded company and for the contracting authority. So Regione Puglia and the company who was awarded with the public tender. And then you can trace the other public tenders from the open and public national database of public tenders awarded by the same company and awarded by the same contracting authority in order to build your investigative case. The dashboard is a communication tool. As you can see, it's very useful if you want to have an idea of which contracting authority or awarded company has a higher risk of corruption. but is a pre-calculated set of data. So you can just look at what the core team project has already calculated. If you want to run your own investigations and calculation, you have to use the CORESOI package, a tool developed by the team of the University of Perugia, by Niccolò particularly, here with us. And while the dashboard aims you to basically consult the results of the calculation, the CORESOI is instead the tool that allows anyone to calculate the indicators on a basket of public procurement data of their choices. So let's see how it works. It may seem difficult, but it's not so difficult. I could use it, so if I could use it, everyone could use it, really. And in any case, the project team will assist you for any further information or advice that you need. I finish here, and Niccolò, the floor is yours.
Okay, so I have to share my screen now. Yes. Oops. So can everybody see my screen?
Yes, perfect.
Yeah, okay, thank you. So, good afternoon, everybody. This is Niccolò Salvini talking. I'm a PhD student at Catholic University of Sacred Hearts in Rome. And here I present the CORESOI package, actually also a way to measure corruption risk during emergencies. And yeah, I'm going to show you how actually I have reasoned throughout all the project, in the sense that from a data scientist perspective, I want to show you how we approach the problem, how do we partially solve the problem, and then how we visualize that at the end. So I'm going to thank you also, Davide, to introduce me. I've already shown the dashboard. Yeah, the dashboard is actually the front end. What we've developed together with the University of Perugia and other collaborators is Dataninja as well, is the back end. So what the data that's running behind the front end, you see. So you should see that the front end it's like what you see of a car. The engine is like the data, and then the algorithms that are under the car, so and within the car. So yes, what we're going to see together is we have a problem and we need to find a solution. So we'll pass through each of the single steps that we've run through in this 2 years long project. So I'm trying to condense as much information as I can into this presentation, 30 minutes long. I don't want to do a mess up, so please stop me if something is not clear, or maybe in the 10-minute section that's going to happen at the end. Please, note the question and I will try to address them. So the first thing is going to understand how to measure corruption, and I'm going to give you a data-driven approach, or at least what I thought and what the literature that is out there think about corruption. And then we're going to see what data is about. So when we're talking about corruption data, where does data come from, and how much is this data, and where it is actually. Then we're going to see briefly, these are going to be very fast slides, because this is not part of this workshop, but it's really important to understand where data come from and how we did this huge calculation. It's very, very, from a computational perspective, huge calculation. So, and that is to say the data pipeline. In the end, we're going to see the CORESOI, and I'll show you a live demo. And hopefully you understand how to run this analysis on your laptop. And you're not going to need anything installed on your computer. We are going to open up a session on a cloud, and so that you just have to log in and then click on the workshop link, and then our studio environment will open up for you. Yeah, what about the learning outcomes? So what we're going to see together is we're going to understand, at least hopefully at the end of this session, you're going to understand how to see corruption during emergencies. Then you're going to have an high-level idea where data came from and how we managed to have it. Then basic uses of CORESOI, So basic functions, how to run indicators. We are going to see a couple of them. And then in the end, also, hopefully, this is all throughout the whole presentation. I'm expecting you to give some ideas on how to run your own project using R. For example, I'm going to show you from code how to print a PDF. So maybe you want to have a report to deliver to your partner, to your stakeholder, whatever it is. Then from code and from the actual CORESOI package, you can deliver a PDF. You can build a web application of that, and just a full-fledged website, let's say. So you're going to have some HTML and then play with it. So it's going to be interactive. Okay, so how do we measure risk in corruption? Measure the corruption. This is the end. This is the question, the important question. So the thing here is, in a normal way, in a very standard environment, if here I say in a funny way, if the world were a beautiful place, you take the data, you clean the data, then you train a model, and then you measure the performance of this model. Maybe you want to train some models, and then you select the best model that performs, in the sense that performs better with respect to a metric, a statistics that you want to consider. And so what you have, you see that below, you're going to have on the left part, this is your Excel file, your CSV file, your JSON file. Since I assume you're familiar with Excel files, so you're going to have a lot of rows and a lot of columns, where columns are variables, are the variables you want to consider. Rows are the ID of the contract or IDs of the companies or the contracting authorities. And then on the right-hand side, you're going to have like if it's corrupted or if it's not corrupted. Then based on this, you can build a train set and a test set. You train your model on the train set and you verify the model on the out of sample set, so on the test set. So what you're basically doing is you're just retaining part of your data set, of your Excel file, some rows. You train the model on some rows, not the whole data set, but some rows, and then you test the model performance on the rows that are outside the sample you did just a couple of moments ago. Then once you have this model, you're going to have a y, which is the response variable, and then some betas, one beta for each variable, so that you can actually give an importance to each variable, and this importance is the contribution to being corrupted or not corrupted. In this case, since it's a binary variable, we're going to have a classification, not regression, and hopefully in the end you're going to have a very, 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 very simple confusion matrix where you want to see the true positive and the true negative. So if the person who's corrupted is actually detected by the model, or the person is not corrupted, is not detected by the model. So you want to basically have a classificator that given the variables that regards contracting authorities, regards winners, and the whole contract. Based on this, you can say, hey, this is corrupted, hey, this is not corrupted, when a new observation comes into your Excel. But the thing is, this is not reality. The most of the time, you don't have this type of Excel file. You really don't have it, because the workflow, the most of the time, is you take data, you clean this data, but then the data gets updated, so you have to reclean it, but then data changes at some point, but then data is missing at some point. And so what you have is an Excel file with a lot of NAs, and for NAs, I mean not assigned, so it's empty right there. Or you have many repetitions, or maybe you have variables which are encoded in a wrong way. Let's say you want to say that this contract belongs to a precise category, and you say you encode this category as 1 and the other category is 2, and maybe the next contract is encoded as 12. So is it 1? Is it 2? Does it mean 12? So the thing is, you have to always face raw data, and raw data it always comes with huge mistakes. And so what you do is you imputate. So input your data. So when something is missing, you try to fill it up by looking at the exact same variables or the variables that are right, that are somewhat related to this. You try to leave out the duplication, so you try to squeeze instead of having like the same row twice, you just have one, and you select, like, let's say the first one, and then you also want to do some feature engineering. So you want to build some other variables on top of the variables that you already have. Yeah, okay. So if this is simple, then the thing that actually it's very brutal in the case of corruption is that you don't have a variable that says if the person is corrupted or not corrupted. You have it after a while. You have it like 1 year, 2 years, and the worst thing is that you are not sure about this, because I can really trust the trial, the judge, but I'm not really sure if it's true or not. It's just, you know, an error from a judge, or it could be also the other way around. So it's if someone is not really detected, then indeed it's actually a corrupted. It's actually a bad person. But assuming that you don't care about this, then you have to build a model. And as I was suggesting right before, you have to build a probability model. So something that assigned a probability to being corrupted or not. And then once you've done that, you should define a threshold. And if the threshold is too low, you're not going to define to find anyone corrupted. So your model is useless, basically. And also, if the threshold is really low, then everybody is corrupted, and the model still is useless as well. So the thing is, it's very difficult to assess corruption. It's a very hard challenge still unsolved, or in some way I will show you how people actually approach this problem now, given the literature that we have. So how do we measure corruption? So corruption, as David already said, is a challenging threat, and is actually a latent phenomenon. So you don't really see manifested. As a result, it has a latent manifestation. So Gnaldi in 2021 did a comprehensive overview of this project, of this phenomenon. And you have different type of measures. You have measures which are perception-based or non-perception-based. The one we are addressing are non-perception-based, and judicial measures. So you might take also the variables coming from the sentence, so the trial sentence. Yeah, let me at first at least introduce you how the procurement process works. So basically, what it's essential to show this, because in the end you'll understand why we are running we are using CORESOI in a way with respect to one another. So you have the contracting authority on the left. The contracting authority publishes the tender. Then in the tender, many bidders participate. So everybody submits his bid. Then with different type of offers, let's say. So you have a lower economic offer, maybe some more features for bidder 2, maybe some more services for bidder 3. Then all the things goes through an evaluation process. Then once the evaluation process is done, the winner takes it all. So let's say the winner is the bidder 2, and then bidder 2 gets the appointment, and the data it's pushed to the ANAC portal. So the ANAC portal is an open source portal. We'll see in a minute what it is, but it registers each of the steps of this. Of this, let's say, pipeline, if I'm using a term that's we are going to see in a minute. So basically, the important thing you have to understand is that there are 3 subjects. So subject 1, which is the contracting authority. Subject 2, which are what we called participants to the tender, and then subject 3, which is the winner. So we might want to calculate indicators for each of these 3 different subjects. As a matter of fact, as I was showing you before, you cannot build a model. Instead, you have to build red flags. So something that is preventive. You don't want to repress anything. You want to prevent the corruption before it isn't even happened. So red flags are these type of indicators that reports anomalies or risk related to misconduct and bad practices. Carloni clearly explained in 2017 in a very, very well-cited article. And there are 7 red flags for corruption. And Fazekas, which is the top, let me say this in an informal way, a top player for the corruption literature, address this problem really well. The thing is, we are not, since the core is not really preventing corruption, is preventing corruption in emergency. The main idea is that the thing that we were measuring right before are not, with respective red flags, are not the one we are going to measure again. So those are different things for a few reasons. One of these is that during emergency, you are going to have emergency measures as a result. So you are going to relax typical safeguard against corruption through exchange of compliance, because you want to essentially have a rapid procurement to secure goods to people. Traditional red flags as a result are not good. So what we propose, which is novelty in the literature actually, we are the first to try to approach this problem in this way. In the left part, you see the indicator one definition. So, we define a set of indicators. David already showed you. It's 9. It's a set of 9 indicators. This is the first one. So indicator one actually does this. So it focuses on companies that after the emergency outbreak were awarded public contracts much more frequently than before the emergency. So essentially, you're measuring is the number of contracts for these contracting authorities, since in this case, indicator one is addressing companies, in this case, not contracting authorities. So for each company, you are going to measure the number of contracts after the emergency outbreak. So let's say, let's truncate the timeline in pre and post. Pre, before the emergency outbreak, let's say March 2020. And after the emergency outbreak, so after March 2030. So you measure the number of contracts awarded, and then you do a simple statistical hypothesis testing in which you want to assess if there is statistical significance between the post and the pre. So if the result is yes, so if the mathematics part works, then you assign 1. So this red flag is actually on. So company A has red flag on. If that is not the case, so there is not any sufficient statistical evidence to say that, because the p-value is low, because you cannot compute for this particular company, then the output is 0. And this is also true for all of the other indicators you're going to see. So I'll briefly introduce you also to the composite. So basically, all the indicators just look at a different type of corruption, a different angle of a company or a contracting authorities or a bidder corruption. So what you want to do really is that you want to assess if this person is actually corrupted by different type of way to see that. So you want to combine all the indicators together, assign a weight, and the thing we did together is that we tried to give some experts a way to assign weights to each of the indicators in order to compose them and then to produce a composite indicator. And also we applied a measure, a thing data induced. So it actually the mechanism is that data regulates itself, so that both the expert judgment and data judgment is condensed as well. And you at the end, you're going to have your composite indicator. Okay, what about data sources? We have a couple of them. I'll briefly skim through it. So the thing is that you have the most important data source that we have is Banca Nazionale dei Contratti Pubblici. It's enormous. It contains many information. It's maintained by ANAC. You see some numbers here. You see 60 million contracts, 3 trillion euros exchange, 39,000 contracting authorities. There are 2 types of offers. It's CIG. So CIG for those contracts that economic value is greater than 40K, and those who are below 40K. And it comes in many formats. So you have CSV, you have JSON, and also OCDS. For those who do not know, OCDS is just a standard way to distribute this type of data across the Europe. So it's a standard. It's a standard data format. So if you want to distribute your ANAC data, so your Italian data, to OCDS, you should adapt your data to OCDS. That is to say, you have to reduce the number of information you want to let's say, give it out. The other important data source is OpenTender. OpenTender still is very important. It enables transparency in European public procurement. It has advanced search and filtering option. And basically what it does is just grabs from all the other countries in Europe data, and then it standardizes in an OCDS way so that they can be compared, they can be filtered, and that's it. So what we did is just we grab data from ANAC, and then we grab data from OpenTender. So you should assume that these data are massive, and you will see how we combine that. And we did it by by orchestrating a different set of technologies, cloud technologies. So you have, as you might see in the upper left part of the screen, data coming from ANAC. We use the Lambda web scraping. We use web scraping through a Lambda function, which is an AWS service cloud provider. We scraped on a given schedule data, and then we put it on our database. And this is also true for OpenTender. So once all this data is in our database, we open up a further machine. We open up a further machine, virtual machine, which actually aggregates all this data and computes quality. Do you remember that there is the passage from data source to clean data? So you take data, you clean data. This is the passage I was referring to. So you clean the data, you impute this data, you calculate features from this data, and so on and so forth. And those are the three technologies that we use: Glue, Data Catalog, and Athena. In the end, once we have this huge file, which considers 10 million rows, but this is in the very beginning. Now we have much more than that. We kind of open a further machine, so a further virtual machine, on which we install our package that we're going to discuss in a few minutes. And we get this data from the other machine. We process this data with our package, and then we produce, as a result, the indicators that I was showing you. So we calculate all the red flags. So red flags 1, 2, 3, 4, 5, up until 9. Then we calculate also the composite. In the end, we are going to have some files that are going to be distributed to the dashboard. So now you have the whole circle completed. So you get the data, you have the pipeline that processes data, then you have the package that computes the indicator, the red flags. Then from the red flags, you get the files, and in the end, you represent these files through a dashboard. Very simple as that. These are other things that we did. We did some integration. We grabbed some data from Instat, grabbed some data from Atoka as well. And then also in the end, we tried we did it actually to have an API so that you can directly, instead of having like the whole pipeline set up for you by yourself, is not open for sure, you can directly grab our data from our database. This is essentially the last part. So as I was referring to, we have all this data from indicators, and through another set of technology, you have the dashboard. And let me show you also the dashboard in an interactive way. So this is the dashboard. Basically, you start from here. You select the emergency. You are interested. Sorry, the country you are interested in. Let's say Italy. Then let's say you want to see COVID-19. So we select COVID-19. Let's give you some time. Okay, and this is indicator, the composite indicator in emergency for COVID-19. Maybe you want to look at indicator 3. So and right after in the map pops up the values for indicators with respect to the aggregation. So we have regions here, but we also have provinces. Okay, so and aggregations are just a way to, so you see regions and provinces, but indicators are actually calculated on, let's say, on contracting authorities and on companies, and then aggregated by at a regional level. Okay, so what we have is an ecosystem to assess corruption, CORESOI, the CORESOI package, but as well we have a container which is called CoreForge that contains the CORESOI package, a Core package which is a WIP, so a work in progress package still, and then And then yes, so basically this is the whole software assets of this project. Here I show you very briefly the API docs, so you can really query our database looking for different things. You cannot look for indicatori and red flags since they are already in the dashboard. Yes, those are the resources. I'll leave the slides for you if you want to have a deeper look. But for now, let's dive into the live coding stuff since we have 10 minutes left, and I want you to show you how it actually works. So what I'll ask you is that if you want, you can go directly to this link. I'll distribute in the chat in a minute. Oops. Is this one? No, it doesn't open. Oops. Let me try to. Okay. Anyway, let me try to grab it from here. Okay, this is the link in the chat. There we go. And yeah, what you are going to see together is a process. You're going to log into Deposit Cloud, and then you're going to accept, if you want, the invitation for the CORESOI workshop. And then you're going to click on CORESOI workspace, and you're going to end up in this. In this workspace. Let's give some time to load it.
Yeah, Niccolò, I just shared the link with everyone in the chat because I thought you sent just to us as panelists, but I think that
I'm sorry.
No,
about
no
this.
problem, no problem.
So let's give some time to it. Okay, there we go. So I've already compiled notebooks for you, so we don't have to run code back again since calculations are actually a little bit heavy in this case. So I will try to show you already the results for it. Let me show the code for this. So this is the introduction. CORESOI is a powerful tool again to analyze and interpret data with a focus on social impact. I'll try to demonstrate its functioning. It's the very basic usage. So if you want to install it and run on your computer, this is the thing you have to do. This is the source code. You can copy and paste and then directly on your console, and this is going to happen. I opened up this machine, this cloud machine, with all the packages that are needed for this analysis. So you don't have to run it again and install it again. But if you want to run it on your computer, maybe you have R, maybe you are interested in the project and you develop a passion for statistical programming language, this is the way to do that. So you should install from GitHub. It's not available on CRAN, which is the package repository by RStudio. So once you have installed that, you want to load this package. You do it by telling to our library CORESOI. And then contained in this package, this is one of the most important part of this. We have the mock data core. What it is mock data core? So what I did is I packaged in this package. I'm sorry for the repetition. A little bit, a sample of 300,000 contracts directly extracted from our database. So what you have here is that you have 300,000 dataset, 300,000 rows, and 39 columns directly pumped up from our database. And this is cool because you can quickly have a glimpse of how data is after our preprocessing step, and how we calculate really and in red flags, which are then served to the dashboard. So you can really have a grasp of the backend that powers the dashboard. So maybe you are interested in seeing what is the distribution of contract values. So an histogram might fit for you. So what I did is I used the package of ggplot. It's a very fancy package. Maybe some of you already know. It's a package to do visualization. What you do is you put mock data core into the ggplot. You specify the x-axis in Portolotto. Here applied a scale of logarithm 10 since contracts are most of the time scattered through a precise amount, so you're not going to see anything different from just a bar, a vertical bar. So in this way, you see this distribution is actually, well, I will guess maybe it's a normal one. And you see the frequency of that. Maybe you are interested in the number of contracts by type. So what you do is, once again, you load some other packages to pre-process data. Deployer is one of them. It's very useful. If you're interested into this one, I've developed some tutorial on how to use deployer and how to make use of all the tidyverse, let's say, tools to analyze data. So maybe, again, you want to look at the number of contracts by type. So you load this package deployer, you load the ggplot2, you load the stringer package that allows you to manipulate string. And what you do is you count, in this case, you count the tipo scelta contraente. So this is a special type of, is a category of contracts. You filter by, you just want to take the top 5 and you visualize it here. So maybe you see that the most, it's something which is called affidamento diretto, and the most of the contracts are that way. And then procedura diretta. So the most of the contracts are either affidamento diretto or procedura diretta. Maybe you are interested to see the contracts awarded over time. So let's plot a time series. So in this way, you can see, since we have collected data throughout all the years, this wasn't, I didn't tell you that, but you can also grab historical data. So we grabbed all of them. And by this, you can see each year how many contracts have been published by ANAC, BDNCP, and also OpenTender. And yeah, so basically what you observe is that in the first year, they published a lot of contracts, and then this goes down, but then it kind of finds its way on a normal level, more or less 350,000 contracts per year, let's say. And maybe you want to see the geographical distribution of contracts. Maybe you're interested into your region, and so what you do is you take the data, you factorize the nome regione, since it's part of our database and data set contained in Datacore, and you see that Lazio is the one, as expected, is the one with the most contracts. Then also Lombardia is expected. Then Molise, it's the little one here. And yeah, so basically you can have a grasp of the distribution of contracts in a geographical way. Notice that there are a number of NAs in here. Let's also see what is the average contract value by region. This is the thing you've already done, but you want to see the average contract. You want to see the average value of the contract per each region. I'm sorry. So again, in Lazio, the value of the contract is really high. Maybe it's due to the fact that there's Rome, there's many of them. So maybe that is the case. But the second one still, it's Lombardia. So maybe a good predictor to say the amount of contract, the average amount is by how many of them are already published in that specific region. When I produced this graph, I didn't expect that Toscana was so low. But then Toscana is behind Veneto and then Campania. A huge number of NAs is available right there. But then let's dive into the indicator in the proper usage of CORESOI. So we have a set of different indicators. We have indicator 1 up until 9. The way to do that is to have for each indicators, for each red flags, there is a corresponding function in the package. I'm not going to dive too deep into this, since there is explicitly a documentation of this package here. So I'll grab this link and I'll send it to you. And for all the indicators, as I already mentioned, there is a corresponding function. And then by using this function, you can calculate the corresponding red flag, so the value of the corresponding red flag under a predefined schema, which is contained in this generated indicator schema. Although you don't really care about that. Let me go back to this. No, it's this one. Yes, so basically what you do is you plug in your data, you get the publication date, date. So you provide to this the column that corresponds to the publication date on your data set. In our sample data set is called as well publication date. You provide the name of the emergency. Maybe you're interested in coronavirus, so you plug in coronavirus. You provide here the statistical unit. What does that mean? So we saw 3 different subjects. We have companies, we have contracting authorities, we have bidders. You provide to this one of the 3, and then you apply the test type. Don't care about the test type so much, since it's a very statistical heavy and really ugly stuff to assess, to see. However, there is a default which goes into the Fisher, so you can really not specify that and get the results for indicator 1. This is also true for all the other indicators. Let me go through the. So this is one. I'm sorry, package. Okay, there we go. Red flag number 1. What is it about? Function 1. It computes a winning rate across a crisis indicator for companies, just for companies, focusing on how frequency of being awarded public contracts changes in response to an emergency outbreak. We already seen that, okay? So do you remember that the number of contracts after the emergency outbreak, you count them and you compare them with the one that prior the emergency outbreak. So the function call parameters are this one. So you provide your data. Maybe you want to provide the mock data core straight after. You do the publication date, you do the emergency, you do the statistical unit, you do the test type. Remember, this is default, and this still is default. So what you really have to do is that you just have to plug in the publication date and your data. So just a couple of arguments. What are the results? Results are something like this. So I'm sorry for the plot. It's just a mess because each of the name of the companies is overlapping. But what you can see is that for some companies the red flag in this case opens up, and from some other it's not going to happen. So red flags tells me that for company we don't really know. In this case, is the red flag is open, and so it's kind of, you're looking at something that from this perspective, it's, let's say, drives you. It's a proxy of corruption. What you can do with the same thing, you should imagine this is all done by code. So I'll provide it to you, whatever, all the codes that reproduces this analysis. This is the code to reproduce this type of table. So what you see is that BDC Laboratories was company ID is this one. You should know that this is Codice Fiscale, and it's already it's a wrong one. For emergency ID, for emergency coronavirus in Italy, has value 1. CG Group SPA was Codice Fiscale is this one. For emergency coronavirus, has values 1. So many of them, I filtered out for all the for which the red, for those who have red flags open. So all the potentially corrupted companies. So here you can see a sneak peek on each of the company that probably in some way has done something which can be potentially harmful. Okay, let me go through the second red flags in this case. So I'm already after the time I'm required. I'll briefly skim through this. So indicator 2, what does indicator 2 do? It focuses on the economic impact of crisis on company performance, specifically in terms of public contracts. It aims to spotlight companies that have been a substantial increase in the economic value. So what you are doing is, as you've done for indicator 1, you're computing the value after the emergency, the total value for that company after the emergency, and you're comparing the total value of them for this emergency prior the company. Okay, prior the emergency, and you're comparing the two measures with an hypothesis test. Again, here you have to supply just the data, the contract value, so the column that corresponds to the contract value, and the publication date. Also, as well, the emergency name with the statistical unit. Those two are just by default set by the algorithm. Okay, let's see some visualization. Still, I have produce some plotting here. You see all the companies that have this red flag on. We have Wistar SRL, B4 Pharma Italia, Società Responsabilità Limitata, Vanity Fair di Lamezia. Those are potentially, according to what is indicator to potentially harmful companies. Here you see as well a little mess on the left part, but you see something that you can see the distribution across all the entities. By entities, I mean all the companies for all the data set, for the 300,000 sample that are contained in the mock data core. So some of them are really red, which means the red flag is really open in this case. For some of them, is not really the case. So, and you see that in a less blue, in a weaker blue. Okay, let's see if the top 10 corrupted according to indicator 2. We have a fancy table still in here. So Gomez RL is the one. It has a messed up aggregation ID. This codice fiscal this is wrong again. So, but this is the data you have to deal with it. You have to deal with. We have Ravaglia, Sider, SNC, Ravaglia Bruno, etc. For this codice fiscale, still corrupted, maybe. And then we have Sunny Farm, SR, and this is also true for, I just selected the first 10 rows. Okay. So, what in the end I want to show you, and it's an application. This is the last part. We are just trying to play it around. The thing is, R is a very powerful statistical programming language. You can do analysis if you know how to use it, but you can also build applications. And applications are really useful if you want to represent a phenomenon, or maybe you just want to display something to your colleague, to the other journalists that you have right after you. So in here, in this very basic web application, you can select the column and get the resulting statistics from that column. It's not that really difficult to build something like that and to productionize something like that. This is not a dashboard for sure, so this is not Dataninja work, which is much more heavy, much more important with respect to this. But the main reason why I'll show you this is that if you want to address a phenomenon, which is corruption in this case, you should have a theoretical understanding, a theoretical framework on which you want to work, and then apply this framework with a programming language. But also, in the end, you have to show these results. And a way to show these results is to, for example, building on a web application or building fancy charts, a website, whatever you want. Yeah, so, and actually R offers you these tools. So maybe you want to investigate and go deep into the R statistical programming language as a means to communicate your results, to communicate your analysis, to investigate further on your specific domain. Okay, so I finished with 10 minutes. 10 minutes late. I'm sorry for this. So we don't have so much time for discussion.
Oh, don't worry. I think you were actually very organized in keeping a schedule and dealing with so many more technical aspects. So thank you, Niccolò. And so for everyone, we are accepting questions. You can use the chat. And as a reminder, this is just to give you an insight of what is possible to do with data, with R, and with the CORESOI package to investigate corruption. You are, of course, welcome to get in touch with us or with the speakers if you want to dig into this further, if you are interested in really putting it in practice, but perhaps need some more technical support, installation issues, or whatever. You are really welcome to reach out to us, and we will forward your request to the rest of the CORESOI team. So yes, the floor is open to questions. And in the meantime, also some links are appearing in the chat for all of you who want to know more. So I just see there is one question which was about the password to enter the space with the code, but I think, correct me if I'm wrong, you didn't really need a password, you just needed to sign up to the service. Like I used Gmail, for example, to enter. And okay, perfect. Thank you, George. Sorry, I only saw the question now. Okay, so we have a question from Andrea about whether it's possible to get the presentation. Usually, yes. I don't know if this is a problem for Niccolò and Davide to share the presentation with us so that we can send it to everyone.
No problem.
No problem for me. Actually, I forgot to say, I think, we have a questionnaire, evaluation questionnaire I want to distribute so that maybe we can have a feedback on the things that we shared with you, and then we can improve. So maybe if I can, Alicia, I'll share the screen, and so
otherwise, if you want, you can send it to us and we will forward it to everybody through the email that we will send as a follow-up to the webinar, so we can share the slides and we will share also the questionnaire. Okay. If you don't have anything particular to say, otherwise, yeah.
No. Yeah, so I'll share also the short link. In the meanwhile, if they want, they can take the QR, they can take a picture of the QR, and then it's going to be a Google form, very simple, very, very short. And feedbacks are really important to us, like so that we can improve. And maybe it's too technical, maybe it's less technical than what you expect. So it's always important. So I assume everybody had the chance to scan that. Okay.
Yeah, so I don't see any other questions in the Q&A, which could be a good sign, or maybe there's still a lot to process as well, which is perfectly reasonable. I mean, even myself, I think I will need to look at it again, putting the pause button sometimes to just go over things. But this was the idea, to show you like how many things are really possible with all of this. And so, yes, get in touch with us if you want to go dig deeper into this. Oh, so we have another question, sorry, in another chat, which I didn't see, which is whether we can use this tool for any country.
Okay. Yes. So, Aniki, thank you for the questions. The thing is, yes, is a huge yes. We can use for other countries. So countries available are actually, let me check. We have Italy, we have Spain, we have Ireland, and we have Portugal. But for Italy, we have a set of 3 different emergencies you want to consider. We have COVID-19, we have forest fires in Italy, and we have earthquakes in the central Italy. Those are different periods. Let's say COVID, I'm not going to tell you when it happened. You have forest in Italy, which is 2017, 2018. We have earthquakes in Italy in 2016 and 2023. The thing here is for the other countries, so Spain, Ireland, and Portugal, again, the only emergency available is COVID-19 for this. But till now, like we are going to develop maybe, hopefully in the future, also for the other emergencies.
Okay, so if there are no more questions, we are ending perfectly on time. So thank you to both our speakers again, and thank you all for remaining with us for this hour. And we look forward to see you in the next appointment of our live webinars. Bye, everyone.
Thank you. Bye.
Bye. Thank you.